In this video, we will be going over the solutions for the end of Chapter 11 test review, and the topic for Chapter 11 was statistical measures. Question 1. A shop records the number of specialty shirts sold each month. In January, the shop sold 75 shirts. In February, 68 shirts. In March, 75 shirts. In April, 92 shirts. And in May, 105 shirts. Our first question asks, what is the mean number of t-shirts sold? The mean is the average. To find the mean, you first add up all of the t-shirts sold, then you divide it by the number of data points that you have. The sum of 75 plus 68 plus 75 plus 92 plus 105 is 415 shirts in all were sold over a 5-month period. 1, 2, 3, 4, 5. So we're going to divide by 5. You may use a calculator throughout this assessment, and if you solve 415 divided by 5, you'll get 83. The average or mean number of t-shirts sold each month were 83. Next question, which measure of center best represents the data? As you look at your data, there really isn't a significant outlier, but 105 is a little bit further outside than the rest of the data, so you could say that 105 is an outlier. The range would be the minimum between the minimum and the maximum, the difference between those two. The maximum is 105, the minimum is 68, so we can find the difference, which would be 37. The mode is the most often occurring piece of data. 75 t-shirts sold occurs twice, whereas the rest of the amounts only occur once. So the mode is 75. We have already figured out the mean to be 83. Now, when we look at all of our choices here, we're asked to find the best representation of the data. That's all of the data. When I look at the outlier, 105 is only taking into consideration one piece of data, the one piece that's the furthest outside of all the other data that we have. So this is definitely not a good representation of all of the data. The range only considers the minimum and the maximum. The rest of the pieces of data don't have an impact on the range, just the minimum and the maximum. Similarly, the mode. The only number that affected the mode was 75. It was the most often occurring piece of data, but the other pieces of data have no effect on the mode. The mean is the only choice that involves every piece of data. If I take one of the data pieces out, it will affect the mean. Question number 2. The following is a list of the ages of people attending a concert. Write the ages in order from least to greatest. 2, 7, 19, 22, 22, 24, 25, 25, 28, 32, 41. Part A. What is the median? Remember, the median is the middle number. If you think of a median strip on a highway, it's either the concrete barrier in the middle of the road, or in a city you might have a median strip that's grass. Again, though, the median strip is a strip in the middle of the road. So we're trying to find the middle piece of data. So we count from the outside in. 1, 2, 3, 4, 1, 2, 3, 4, 1, 1. Our middle data point is 24. The range is the maximum minus the minimum, the difference. So that's 41 take away 2, which equals 39. The mode is the most often occurring piece of data. 22 appears twice. 25 appears twice. You can have more than one mode. All of the other pieces of data only appear once. So our mode will be 22 and 25. The maximum is 41. The minimum is 2. Question 3. Below is a frequency graph that illustrates the number of cupcakes sold over 15 days. Use the frequency table below to determine the mean number of cupcakes sold. Round to the nearest whole number. If you're working quickly, you may add up all of these numbers and then divide by 1, 2, 3, 4, 5, 6, 7. But this is a frequency graph or frequency chart. This 5 is telling me that for 5 days, 5 cupcakes were sold. For 2 days, 7 cupcakes were sold. 3 days, each of the 3 days, 10 cupcakes were sold. So this 3 actually represents 30 because it's 10, 10, and 10. So when you have a graph like this or a chart like this, what you need to do is record your data first. For 5 days, 5 cupcakes were sold each day. That will be 5 plus 5 plus 5 plus 5 plus 5. 1, 2, 3, 4, 5. For 2 days, 7 cupcakes were sold each day. That's 7 plus 7. For 3 days, 10 cupcakes were sold each day. 10 plus 10 plus 10. 1 day, 12 cupcakes were sold. 2 days, 21 cupcakes were sold each of those 2 days. Another day, 24 were sold. And another day, 28 were sold. Notice I have 15 pieces of data because I sold cupcakes over 15 days. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. To find the mean, we're going to add up all of the number of cupcakes sold, and we get 175 cupcakes sold in all. I'm going to divide that by the 15 days, and that gives me 11.6 repeating. Now, because you can't sell 6/10 of a cupcake, we're going to round this to 12. So the mean number of cupcakes sold were 12 cupcakes. Question number 4. The students in one social studies class were asked how many siblings, brothers and sisters, they have. The dot plot below shows the results. How many of the students have 6 siblings? 1. How many of the students have no siblings? 3. How many of the students have 3 or more siblings? That would be here over. 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. What is the median? I'm going to list all of my data in order from least to greatest. 0, 0, 0, 1, 1, 1, 2, 2, 2. There's 1, 2, 3, 4, 5, 6. 3, 3, 3, 3, 3, 3. Then I have 1, 2, 3, 4 4s. And 1 6. So the median is the middle number. So So I'm going to count in 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 3, 1, 1. Now there are two numbers in the middle, and fortunately for us, they're the same number. So what would be in the middle of 3 and 3? It would be 3. So the median is 3. The mode is the most often occurring piece of data. In this case, most of the people had 3 siblings. How did you determine the mode? The mode is 3 because having 3 siblings is the most often occurring amount. Question number 5. Paul took a survey of the number of shoes people own in his neighborhood. Unfortunately, he spilled his drink on his record sheet and he cannot read the first entry. He remembers that the range was 22. What must the first piece of data have been? Well, to look at our data a little bit more organized, we're going to put them in order from least to greatest. So we have a question mark, and then we have 5, 6, 7, 8, 12, 16, 25. So that's our data now in order from least to greatest. He remembers that the range was 22. Range equals the maximum minus the minimum. We know the range was 22, and we know the maximum is 25. We don't know what the minimum is. That's our question mark. So 25 take away what is going to give me 22? Well, 25 take away 3 equals 22. So my missing piece of data must be 3. Question 6. We're given a list of temperatures in degrees Fahrenheit. What is the mean of the temperatures? Show your work. To find the mean, we must first find the sum of all of our temperatures. 72 plus 68 plus 22 plus 63 plus 75 plus 63 plus 65 plus 74. If we add up all of the temperatures, we get a sum of 502. There are 1, 2, 3, 4, 5, 6, 7, 8 temperatures, so we're going to divide by 8, and that gives us 62 and 75 hundredths. So the mean would be 62 and 75 hundredths of a degree, because all of these are temperatures. And we could even put an F there for Fahrenheit. Identify the outlier, then find the mean temperature without the outlier. Round to the nearest hundredth and show your work. Now, if I look at my data, all of my data is in the 60s and in the 70s, except for one number, 22. So I'm going to eliminate that because that is an outlier. So we have 72 plus 68 plus 63 plus 75 plus 63 plus 65 plus 74. And when we add up those numbers, we get 480. We no longer have 8 pieces of data because we took one away. We only have 7. So we're going to divide by 7, and we get 68.57, or 60 78.57 degrees Fahrenheit. Circle the measure that best describes the data. Then explain why you chose this measure. The mean is the average. The mode is the most often occurring. The range is the minimum minus the maximum, and the median is the middle number. Now, when I look to figure out the median, I'm going to start here with the median. We're going to list the data in order from least to greatest. So I'm going to do that. I have to slide my paper up so that you can see, but we have 22, then we have 63, 63, 65, 68, 74, 75. 1, 2, 3, 4, 5, 6, 7. I'm missing one. 63, 70. Oh, 72. Sorry. We have a 72, a 74, and a 75. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. 8. All right. Now the middle number. If we go in. Okay. Right here is our middle number. Now, because we have an even set of data, we don't have an exact middle number, we have two middle numbers. So now we have to figure out what goes in between these two. And that would be, if I list them, 65, 66, 67, 68. So find the middle here, all right, would be right there. So what's between 66 and 67? 66.5. So the median is 66.5. Now, the mean, we said, was 62.75. Mode is not a good representation for the data because it's the most often occurring piece of data, and in this case, we don't have a mode. Everything, oh wait, I'm sorry, we do. We have 63 as the mode. All right, so let's go back here, 63. So 63 is the mode, but our problem is that the mode only takes into account that one piece of data or two pieces of data, 63. It ignores all the other pieces of data, all 6 others. The range would be the maximum, the minimum. So in this case, it would be 75 take away 22, and we get 53. All right. All of our data is above 53 except for the number 22. So that's not really a good representation. So when it all comes down to it, we're really asking ourselves, is the median better or is the mean better? Well, all of our data is above 62.75 except for the number 22. All of our data, it's 63 or above. It's all above 62.75. So that's not a good representation of the data because really the mean you would think would be kind of somewhere towards the center of your data because it would be the average. But because we have that one outlier that's just so low, it greatly impacts our mean. So for this data, the median is better because it is in the middle. And it also does take into account, all the pieces of data because you put them in order. So the median is the correct answer. Now, I typed up my answer so that you could see the reasoning in words. All right. There is one outlier, 22, that brings the mean down quite a bit. All of the temperatures are above the mean of 62.75 except the outlier of 22. Therefore, the mean is not the best representation. The outlier 22 also affects the range a lot as well. The mode is just the most often occurring piece of data. In this case, it is 63, which appears twice. All of the other temperatures appear once. The median, 66.5, would represent the best data, or would represent the data best, because almost all of the data is clustered around that number, and half are above it and half are below it. Question 7. We have a list of various prices for video games. They range from $20 all the way up to $80. Our question asks us to find the mean absolute deviation. When working with students, we tell them to write mean absolute deviation, and then write mean one more time. When you do this, all of your directions are included in the name. We're going to work backwards. When you find the mean absolute deviation, you first find the mean, then you find the deviation, then you change it to its absolute value, and then you find the mean. The directions are basically in the name of what you're doing. So step 1, we're going to find the mean of these numbers. So with a calculator, you can add up all of these prices, and when you do, you'll get a sum of 497. Now, we have to divide by the number of video games we have. There are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to divide by 10, and that's going to give us a mean price of $49.70. So we have accomplished step 1, we found the mean. Step number 2, because working backwards, is to find the deviation. We want to find out how far away each price is from the mean. How far does each price deviate from the mean? We're going to write down our prices. To find the deviation, we're finding the difference between the price and the mean. So we're going to subtract all of these by 49.7. You can add a 0 there, but it's not necessary. And that is going to give us our deviations. All right, so when I put that into a calculator, my answer will be negative 9.7, 5.3, 10.3, negative 1.7, 7.3, negative 16.7, 7.3, negative 29.7, 30.3, and negative 2.7. So I've just figured out the deviations. Step 3 says to convert my deviations to their absolute value. All right, so this would be, I actually might make this a little bit of a chart. So this would be 9.7, 5.3, 10.3, 1.7, 7.3, 16.7, 7.3, 29.7, 30.3, and 2.7. Remember, when you convert a number to its absolute value, you're just basically making all of the numbers positive. Step 4, I have to find the mean again. So I have to add all of these values up. And when I do, I'm going to get a sum is 121. And I have to divide by the number of data points that I have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that will give me $12.10. So the mean absolute deviation is $12.10. How many data values are closer than one mean absolute deviation away from the mean? So how many of these prices are within $12.10 from the mean up here, from the mean? Okay, so I'm going to draw a little number line just so that we can visualize what's happening here. All right, so our minimum was 20. Okay, our maximum was 80. We found the mean to be $49.70. Okay, so we want to know, this would be one mean absolute deviation away. So we add 49.70 plus $12.10, and that's going to give us $61.80. So that would be one mean absolute deviation more, and then one absolute mean deviation less would be $49.70 subtract 12.10, and that would be $37.60. So what they're asking here is, of our data, of our amounts, which games fall within one mean absolute deviation above or one mean absolute deviation below. Okay, so we could actually plot them all here. Okay, we're basically looking for games that are between $37.60 and $61.80. Okay, so we can easily identify that. So I'm going to circle the ones that fall between $37.60 and $61.80. So that'd be this. Okay, so we have 1, 2, 3, 4, 5, 6, 7. We have 7. All right. Now another way to look at it is by actually looking at your absolute deviations. Which numbers are less than 12.10? Well, this is less than 12.10. This is less than 12.10. Less than, less than, less than, and less than. And do they match up? Oops, sorry, I missed that one. Yep. So we have 1, 2, 3, 4, 5, 6, 7. All right. Now, explain how you found your answer above. In the above calculations, I calculated each data's deviation from the mean. I looked for deviations that are less than 12.1. The data points $40, $55, $60, $48, $57, $57, and $47 all have absolute deviations less than $12.10. Question number 8. Find the first and third quartiles of the data. Show your work. Here we have points scored during a game. The first thing we want to do is list them in order from least to greatest. So we have 5, 5, 6, 7, 8, 9, 9, 10, 10, 11, 27. We want to, step 1, find the median. So we count ourselves in. And 9 is our median. Now we want to find the median of the first half of our data, and that will be our first quartile. So we're going to go in and in. So 6 is our middle number. And then over here, we're going to find our middle number, and that's 10. So our first quartile is 6. Our third quartile is 10. Now, the interquartile range is the range between the third and first quartile. So we're going to do 10, take away 6, and we're going to get a range of 4. Are there any outliers? Well, yes, there are. Let's look up here. Are there any outliers? 27 is an outlier. Notice that the data points here are separated by 1. Okay, between 5 and 6 is 1. But the difference between 11 and 27, 27 subtract 11, you'd get 16. So that's a big difference there. Everything else is about 1 away from each other, and then you have a gap of 16. So 27 is an outlier. Okay. And I've typed up my explanation for you so you can see. If you take 27 away, the range would be 11 take away 5, which would equal 6. The range of all of the data would then be only 6. If you take the highest value before 27, which is 11, and find the difference, that is 16, almost 3 times the distance. Therefore, 27 is an outlier. And this concludes our study guide review, and I wish you the best of luck on your test.